Hello, my name is Steve Bowler, and in this video we're going to be taking a look at OSPF. Specifically within OSPF we are going to be taking a look at OSPF timers. So in this video what we're going to do is we're going to look at the OSPF dead interval and the OSPF hello interval. We're going to be taking a look at how to manipulate these values both over a broadcast segment and a non-broadcast segment. So we're going to show you how you can manipulate these values to make your networks run a lot better. So convergence times are a lot faster, and also so that you're not using as much bandwidth over in this case we have a fractional T1 between R1 and R3. So let me go ahead and just explain a little the network. We have three routers, router 1, router 2, and router 3. The link between router 1 and router 2 is a 100 meg fast Ethernet connection, and the network between router 1 and router 2 is the 192.168.12.0/24 network. And then on the left side of our diagram we have router 1 and router 3. And then the link between router 1 and router 3 is a serial link. Again, this is a fractional T1. This is a 128 kilobits per second link. So a pretty slow link. Again, this is on the network 192.168.13.0/24. So let's just show you the interfaces that are connecting these routers together. Router 1 is using serial 00 to connect to router 3's serial 00. And then also router 1 is connecting to router 2 via fast Ethernet 00. So R1 is fast Ethernet 00 and R2 fast Ethernet 00 between the two routers. So in this case we have two different media types we're going to be looking at, and we're going to show you how you can manipulate OSPF timer values. So this is very good to know. The first thing you need to know is for broadcast networks, the default intervals for the hello and dead timers are, the hello is going to be 10 seconds and the dead timer is 40 seconds. And then for non-broadcast networks, the range is for the hello is going to be 30 seconds and the dead timer is going to be 120. So we'll take let's go ahead and put this down here. So we'll go ahead and take a look at these values. We'll show you the default values, and we'll also show you how to manipulate the default values so that you can make, again, convergence times faster between neighbor outages and how to detect those neighbor outages faster. We will also take a look at OSPF fast hellos and the concept of fast hellos and sending sub-second hello messages from router 1 to router 2. Again, this is a 100 meg link. So what we're going to look at in this lab first, let's go ahead and get into router 1. We'll go ahead and set up router 1 first. We'll set up the connection between router 1 and router 3. So the first thing is we'll go under the serial interface, give it the IP address 192.168.13.1/24. Do a no shut on the interface, and then we'll go ahead and create our OSPF instance. First off, good OSPF practice is to give it a router ID. So we'll give OSPF the router ID on R1 of 1.1.1.1. And the next thing we're going to do on R1 is we will, under OSPF process 1, we'll advertise the network 192.168.13.1 into area 0. So this is a pretty flat network design. All of the interfaces are going to be in area 0 in this lab. So there's really no need to segregate the